Okay, everyone, it's time to start again. It's quite clear to me that we made the coffee breaks a little bit too short. Maybe we should rethink that next time. So if you can take your seats, we're going to go into the next session. And after our open forum last year in our satisfaction questionnaires, we got quite a lot of comments that you all guys wanted to hear more from our customers and from the steel-using sectors. And so we were thinking about how we could introduce that into this discussion. And instead of actually inviting sort of customer companies to talk about what they are doing, we decided to focus on 3 different sectors. So that's the construction sector, the automotive sector, and the energy sector. And we are going to start that session now, and let me then start by introducing the moderator. Let me see if I can do this. Mr. Michel VAN HOEY. He's a senior partner at McKinsey's Luxembourg office. He's also leading the Global Materials Insight Group, which is McKinsey's global research and expert consultant organization for the materials sector. So, Michel, the floor is yours.
Thank you very much, Uza, and good morning, everybody. It is my pleasure to introduce and host this exciting session during which representatives from various steel-consuming sectors, the construction sectors, the automotive sectors, the energy sector, will provide their perspective on how they expect their respective industries to develop in the coming years, and what that will mean for the steel industry. It is clear that steel will continue to be a very important material in the low-carbon society of the future, and it will play a critical role in the transition of the automotive, the construction, and the energy sectors. It is, however, also clear that this will require real innovation, new solutions, and cross-chain collaborations. The format of this session will be that each of our 3 steel-consuming industry experts will make a short 20-minute introductory presentation, and those presentations will be followed by a panel discussion during which we will take questions from the floor. So please prepare your questions, think well about what are the things you always wanted to ask to the end-user sectors. Without further ado, let me introduce the 3 panelists. The first one is Dr. Olivier Vassart. He's the Chief Executive Officer of ArcelorMittal Stelligence, and he will be covering the construction sector. Stelligence is a construction approach, for those of you who don't know it, which was developed by ArcelorMittal, and which considers buildings holistically and encourages optimum use of material through the life of the building. The second panelist is Dr. Ingo Olszewski. He is the Head of Strategy and Consulting at FKA Germany, which is a research partner to the automotive industry, and he will obviously be covering the automotive sector. And the third panelist is Mr. Marcel Hilgers. He is the Head of Sales, Technical Customer Service and Communications at ThyssenKrupp Electrical Steel, and he will be covering the energy sector. So I would suggest we first listen to the presentation of Dr. Vassart, and I'm looking forward to these presentations and the panel.
Thank you very much, and thank you to have invited me. So today I'm not representing ArcelorMittal. I'm representing Construct Steel, which is the construction branch of World Steel Association. I have taken an angle of the presentation really from the customer perspective, not at all from us, from the steel industry, but I will try to show you how our customer are looking at decarbonization of steel and what are their issues. So just to show the big numbers. CO2 emission, 40% are emitted in a way or another by the construction and infrastructure industry. So a lot of people are focusing on transportation, on industry, but construction is the biggest chunk of our emission worldwide. And when we look at the numbers, with the growing population, we will need to double the amount of surfaces which have been built up to now just to feed and to house and to have the working areas for the people that will join us on the planet. So think about it. All the buildings we have, we need to keep them. We need to refurbish them to fit with the zero emission policy that we have. And on the top of it, we need to rebuild the same amount of meters squared that we have. That's a really massive challenge. It's a challenge, but it's also an opportunity for steel industry, because also the half of the volumes of the steel industry are ending up in construction. So don't shoot on me. I know that steelmaker and also World Steel doesn't like at all to show numbers per routes of production, but that's what our customers are looking at. So we can do what we want, we can think what we want. These numbers are there. So it's not numbers of ArcelorMittal Mill, it's not numbers coming from World Steel, it's numbers that some of my scientists pick up on the literature. So if we don't want uncontrolled number to reach the market, we need ourselves to put these numbers online. So what they look at: blast furnace, 2.4 tons, DRI, 1.2 tons, EAF, 600 kilo, EAF plus renewable energy, 300 kilo. So this is not crude steel things, because our customers, they don't care about crude steel. What they want is, what's the value of the steel product you ship to me, you put in my building. So this corresponds approximately to hot rolled steel, a coil, a rebar, a beam, a wire. And to make it simple, it's really simple for engineering offices to remember this number. You start from 2.4, and then each time you divide by 2. And it's approximately what they use when they want to assess LCA. Of course, we have a lot of LCA experts in the game, which are using EPDs of the producers and so on. But at the end, that are the average number which are used by the customer. So when they look at this, when I'm engineering office, they say, easy. Why do we speak about decarbonization of steel and so on? I take everything from the bottom right. And I have resolved my solution of decarbonization, my buildings. I use steel coming from EAF with renewable energy. We know all that it's not feasible. We had a big discussion yesterday about scrap, about availability of scrap and so on. If everyone is jumping there, first of all, we don't have enough EAF on the planet. Then even if we start to build massively EAF, we don't have any scrap available on the planet to do this. It means that us, as steelmaker, we still need to continue to educate the market, to teach them and to make them aware that, okay, it's a good solution, but we need also to decarbonize the primary route. So I was looking online after this World Steel graph showing scrap and primary. I could not find it, so I took another one just to show how we need to explain that to the people in the construction market. We have on the left the growth of the steel production worldwide, and on the right a bit of split. Don't look at the numbers. What matters is that you have two colors on the graph. it's the split between what can be done by EAF and what must be done by primary steel, just due to availability of scrap on the planet. So that's the type of thing we need absolutely as steel producer to drain on the market and to make people understanding. Because engineering office, it's clear. I see all of them, all the architects, they go and they say, okay, I want EAF steel. Can you provide me EAF steel? And for them, that's all. Because from their window, when they have an EAF steel, they have a steel with really low carbon, and then in the accounting of their building, they just take this really low carbon value and they have reached their target. So it's, of course, an opportunity for the EAF steel makers on the planet to bring an additional value on the product they do. But at a global scale, it's something that we need to think about. Then, now I will focus on why is it so complex to reach the target of decarbonization. So don't look at the numbers on the right. What I want to show with this graph, the blue line, it's the amount of megatons of material we are using to build the building that we need. So the vertical line, the second one, it's today. And with the growing of the population, with the amount of meter square we need to build, the projections show us that this blue line will continue to grow. And then you have the orange line. The orange line is the CO2 content of this material. And we have the surface in blue and the surface in orange. The orange line on the right, the one which is there, is the trajectory of the CO2 emission if us, the industry, so steel industry, concrete industry, are following our decarbonization path. It means that if we succeed by decarbonization, by decarbonize the steel in the next decade, we will still follow the orange line. It means it's not the solution, it's a part of the solution. But what we want is to bend down this line. It means that we will need to use less stuff in the building we build. And there again, steel has a really big role to play in bending down this line and decreasing the amount of material used. It's a bit schizophrenic for a material producer to tell the market that they need to use less material. But it's also an opportunity, because to use less material, and I will show it afterwards, we need to use more noble material. We need to use more high-strength steel, use more efficiently the material. And there, the steel has a big advantage compared to the competitive material, which does not have on the shelves everything we have. So, just again to give you some order of magnitude of things. So, that's what I can do to decrease the carbon footprint. I can decide to save one flight, New York, Chicago. I will save 1 ton of CO2. I can cut meat, dairy, beers from my diet. I will save 2 tons of CO2 in 1 year. I can stop to drive my car. I will save 3 tons of CO2. By training, I'm structural engineer. If I save 20% of the embedded carbon of a 200-meter tall building structure, I will save 6 million kilos of CO2. It means that structural engineers, they have more opportunity to reduce carbon emission than anyone else on the planet. And this is really important for the steel industry, because these guys are deciding if steel will be used or not in the building. It's not our customer. Our customer, they just build what they are requested to build. It means that as an industry, we need to go closer and closer to these deciders. The issue with construction compared to automotive, unfortunately, is that in automotive, when you put 10 people in a room, you cover 80% of the market. In construction, to cover 80% of the market, you need to put 10 million people in a room. So that's hell of a job to convince all these people. But it's an obligation if we want to reach our target. So just to give you the scale of what can be done with steel. So here is just an example for the column of a building. So on the left, it's a column which is designed with S235, the basic steel, and built without low carbon steel. I took the European average for the calculation. Just to design the same column in S235, you decrease by 40% the carbon emission. Of course, you will use less steel, but when I see the growth of meter square that needs to be built, the demand of steel will grow dramatically. So it's better for us to push and sell higher strength steel. And then if you jump again, you go to S460, and you use low carbon steel. When you combine everything, you can decrease by 80% the carbon emission of the element, because at the end it's what matters. It's to decrease the end user emission, to decrease the emission on the planet. So that's a big opportunity for us, because it can push higher the high-strength steel market. In the past, we were always assessing high-strength steel on the basis of cost. High-strength steel is a bit more costly, it's less available, but it decreased the weight of the building. Today, the CO2 is increasing the value of high-strength steel on the market. So you can go further and take it at the scale of a building. Calculation is a bit more complex, but tendencies are the same. We decrease by 75% the carbon emission when we use higher strength steel and low carbon steel. And finally, when you take a really complex building, there the calculation is more difficult, but the steel intensity is also higher, because in a building, we don't have only structural steel. We have the facade, we have the roof, we have the ventilation, we have the electric tray, we have all the MEP, which are also made of steel, and which are a big market for low carbon steel. So already today, with what is available on the market, we can easily decrease by 35 to 55% the carbon intensity of the construction. So we see another industry, wood, not to name it, which is surfing a lot on the low carbon intensity of wood. But steel is also a really low carbon intensity when it is designed properly and when the right steel is used at the right place. And finally, there is a tendency on the market that could, not tomorrow, but after tomorrow, influence our business model. It is the reuse of structural elements. We see more and more people wanting to go in a direction to be able to reuse elements. And there again, steel has a really good role to play, because on a building, steel is assembled. It means if you assemble it intelligently, you can disassemble it intelligently, and then reuse the element. Today we have several examples, some examples, it's not yet large scale for many technical reasons and also many financial reasons, but with the increased pressure on CO2, we will see the regulator and the customer going more and more into this direction. So this was just an example not far away from my office in Luxembourg. It's the European Court of Justice that has been refurbished by Dominique Perrault. So we had a lot of asbestos into the building. And to remove it, he took a drastic stance. He said, okay, we will dismantle the building. We will not destroy it. We will dismantle it piece by piece. We will clean each pieces, and then we will rebuild it. So that has been done several years ago, and he even changed totally the architecture. He didn't make a one-to-one, but with the reused element, he could do the new building. And here a small other example also in Belgium, in Louvain-la-Neuve, where they have built an office building with reclaimed steel. So in the Netherlands, we see more and more stock available with reclaimed steel, and customers are purchasing it to do new construction. But one thing that needs to be taught again is that if you want to reuse a maximum of elements, you need to think the day you design and the day you build, how you will assemble and disassemble. So here is just a small example of a kind of Ikea building where all the elements are standardized and all the same, and then they are assembled and disassembled, a bit like a Ikea furniture. You have a simple drawing, you can play a bit with the dimension. So this has been done in Esch, close to our mill. It is now disassembled. We will store it for 2 years, just to see what happened, and then we will reassemble it to see if the elements have moved. So it's not only steel elements, concrete and wood elements have been also designed to be disassembled. But that is the type of thing our customers are looking at. So thank you for your attention.
Thank you very much, Dr. Vassar, for this thought-provoking presentation. And I will come back to you later in the panel on what it will really take for these 10 million decision makers in the construction industry to align and to basically reduce the emissions. Let me introduce our next speaker, Dr. Ingo Olszewski.
Yes. Yes, thank you very much, Michel, for the kind introduction, and also thank you very much for the invitation of World Steel, World Auto Steel, and for the perfect event organization. So now let's switch the user perspective to the mobility and to the automotive sector. The automotive sector is in their biggest transformation process since decades. So what we are facing is, or what we saw in the past is, that we have more or less inventions in terms of, for example, in terms of internal combustion engines, in terms of the body structure, in terms of the chassis architecture, for example. But today, we have to come up with innovations in terms of electric mobility, in terms of automated driving, for example. And this is what I would like to show you in my presentation, the perspectives for steel in the mobility sector, and with all the challenges arising around these innovations I've mentioned before. What is the right button? This one. Okay, sorry. So let's take a first look. Like I said, the automotive industry, respectively all the mobility industry, is in their biggest transformation process. And why is this so? So we see these major trends which not only affect the automotive industry, like for example the digitalization or the urbanization or new ecology, demographic change, or the individualization of products, for example. But you see through the interlinks of these major trends that we have to handle a more or less high complexity when it comes to the engineering side. So for sure, decarbonization is one of these factors. And like I said, the business case in this sector of mobility, where the vehicle is right now just only one product in a new evolving circular economy, that's quite a challenge. And therefore, we have to overcome with all the challenges here I've shown you on this slide. When it comes to decarbonization, this is one focus of my presentation. In the mobility sector, we see that we have very, very concrete and enforceable use phase targets. Let me just show you this for Europe. We have globally here in Europe the strictest targets in terms of towards newly registered vehicles. It's the so-called Fit for 55 regulation, that we have to overcome 55% of CO2 reduction compared to 2020 in the next phase until 2030. And you maybe have read it in the press, also in Europe, a lot of countries have announced that cars, newly registered cars, with an internal combustion engine will be banned from the streets from 2035 onwards. So what we can learn from that is that you can make a check mark behind electric mobility. So after 2035, in the automotive industry, nearly every vehicle will have an electric motor and a battery included into the vehicle structure. And this goes in line with also with the targets you can see in China, in the US, or in the Asian markets, lagging a bit behind Europe. But here's what you can see. We are not talking about only electrification. We are talking about the rethinking of the whole mobility scheme, including electrified, shared and automated vehicle fleets. And this is also not only a phenomenon in just one region, it is a worldwide phenomenon. And here you can see from the legislation side, from the regulation side, much things are done in the newer past. Legislation was always the thing which was holding back technology, because from the technology side we were much more further away what we can depict on the streets, but legislation, it was a legislation from the 60s and the beginning 70s, was holding back the automotive industry to show these new vehicles and vehicle concepts with these new functions on the street. So Germany is here a forerunner in terms of the regulations. In the US, for example, maybe you heard of that there are a lot of testing fleets already running on the streets. If you stand on a corner in the San Francisco area and you just look on the streets and you wonder how ride-hailing a vehicle, nearly every 1 or 2 minutes a car from Waymo, Lyft or any other player there comes along the corner and you can drive fully autonomous from A to B with these vehicles. And the market rollout is really running right now. And this is what you can see here. Actually, we have reached really a breakthrough by offering public 24/7 commercial services without a driver. Until the beginning of 2023, you still needed, in those cases, a backup driver. Now you are allowed to drive without a safety driver. And if you look at the end of this funnel, you can see that also here in the US, Cruise and, for example, Waymo are already on the streets with unlimited commercial FMP fleets. FMP stands for Future Mobility Providers in selected areas. And the hotspots for this kind of technical innovation are the metropolitan areas, because they are a nucleus for the realization of this further industry plans. So going back maybe 1 or 2 years ago, we just saw small fleets on the streets. So talking about 5 cars running in a test fleet, collecting data, and just to collect data for getting realistic scenarios for this automated driving process. But now you can see the quantities are rising. And already we have in different regions 200 to 1,000 vehicles on the streets nowadays. And yeah, this is a new game, because we also have new challenges in this market. It's not only the traditional automotive industry anymore, but also, for example, big tech companies are getting into the game. And they are pushing really heavily this topic forward, because they see the business case behind that. And this also means that the vehicle concept and the vehicle structure will change in the near future. Because what we can see on the streets right now today is that we have, more or less conventional vehicles with docked-on camera systems and so on. But this is not the wisest solution for the future. These are only test vehicles. And also the companies displayed here, like Waymo, like Cruise, or like Didi in China, or Zoox also in the US market, they are all rethinking the vehicle structure of the car so that it can really realistically depict the use case which these cars are running in. And so you can see here underneath that they will change to other concepts. Some might say these are people mover shuttle concepts, but you have to face the same challenges with these kind of vehicle concepts on the streets as you have right now. And this is also, nowadays in a reality check, a big issue, because what we see from these fleet testings is that, it is not everything perfect in reality. So maybe you heard of some incidents around with cruise robotaxis where they collide with fire trucks, for example, or a Waymo driving car killed a dog in an unavoidable accident. So what does it mean? We need more or less, again, innovations, and we need to evolve this technology to the next level. And this is heavily done. A future vehicle structure is often much designed and characterized by software, but also we have to take a look on the hardware side. So from the software side and from the intelligence side, we need to bring in more AI and sensor technology into the car to make it much more smoother running on the streets, and not only running on the streets, but also parking is actually a big problem for some of those cars. And then now we skip back to the hardware side of those vehicles. We have a high demand on passive safety. A high demand on passive safety. And this is where the materials come into the game, like for example steel, because passive safety is a must criteria for those cars. Imagine you will step into a robotaxi. Okay, for sure, at first you look, is it fancy? Enough for me to step in, how's the concept and so on, who is the fleet operator, but it must be safe, and this passive safety characteristics have to be involved into this new concepts which I've shown before, and we need to face cost reduction and scalability and use case adaptability when we talk about those vehicle concepts. And passive safety, like I said, is highly demanded because it is a must criteria from the passenger side. Also, if you now step into a conventional vehicle, you directly look up Is there an airbag integrated, and so on and so on. So this is also the demand to those new vehicle concepts. And you see that these future mobility providers not explicitly address those functions. And this is a gap we have to close, because about all the software and the fancy multimedia and the business model running with apps and so on, we have to find solutions in terms of the must criteria of passive safety. And here, for example, what World Auto Steel has done in the past in a program, for example, is really a good thing, because to bring in transparent concepts, like, for example, the steel emotive, how to deal with, for example, short overhangs. Now we have big overhangs, which gives you in a crash much more of this passive safety you have. Now we have only small overhangs because you want to put in people. They think in business cases. You want to put in people into these cars or parcels into this car, and then you need other space, like in these conventional vehicles with motor concepts and so on. Because also the electric motor, has not to be an electric motor which is centralized in the front. It can be in-wheel and so on. Also there we will see a lot of innovations in the next years in those vehicle concepts. Then we need new door concepts. You need the people to get into the car as quick as they can and out of the car as quick as they can. And also as quick as they can out of the car in terms of accidents, for example. Because you are driving with an electric vehicle. All these concepts I've shown you will be electric vehicles. So there's a battery installed, and batteries might or can explode. They should not, but they can. And therefore, we have to think about those safety concepts. And this is also the last point, the battery safety. So the FMPs, like, for example, Zoox, they have it on their agenda, but it's not their top priority. So here, a lot of communications can be done that this should be the top priority also for them to overcome the challenges in passive safety. Because we will have accidents on the streets. We have not only selected areas where they drive, this will not be complete fenced, it will be mixed traffic in the future, and therefore accidents will happen, because we have ambulance services, we have fire trucks running on the street, then the example with the dog, and so on and so on. We will have accidents. And so passive safety is really a high demand in terms of this new mobility concepts. And here's what we can see, not only the passive safety, but also it should be scalable to bring down the cost, so that you have, for example, one vehicle platform, and you couldn't put or depict it in different use cases. I will show on my next slide what these use cases can be. And it should not be only be scalable, but also the upgradability should also be secured, so that there can be systems replaced. And the same tendencies, you know, when you look at your smartphone. Like, for example, with all the legislation which is coming now in terms of repairability and so on, it's nearly the same there. Because this car is running no longer for you in private, but it's running in big fleets, and therefore these cars have to overcome these challenges in terms of maintenance, repairability, upgradability, and so on. And this use case adaptability is really an important topic, because it will cover a variety of people and goods transportation services. So you can depict with one platform maybe different use cases, like shown at the bottom of the slide. It can be basic comfort, it can be premium comfort, it can be productivity, or any specific purposes, for example. And then this vehicle concept has to fulfill all these different use cases. So you need, for example, one chassis platform or one body structure, and the interior maybe is a little bit different in these different use cases. And here also, for example, you see that this steel emotive concept also fits into both of the worlds, including the single-use mass mobility as a service models or the pool mobility as a service models. And you can see also here from the status quo to future automated mobility as a service, the vehicle will change. Yeah, and this brings me to some implications for the steel industry. Yeah, you can see here that in principle steel has very beneficial characteristics for the application in both conventional vehicles as well in this new vehicle concepts in terms of costs, in terms of safety, and in terms of, for example, sustainability. But as I mentioned before, the game is changing in this mobility and automotive industry. You also have to deal with the new challenges, because they are setting up the demands for those vehicle concepts which I have shown you before. And therefore, it is worthwhile also to address their demands with your steel solutions. And especially when it comes to these innovative vehicle concepts, it may create a market pull for high-performance steel grades, for example, to fully exploit design spaces. And like I shown before, there are a lot of challenges in terms of passive safety then, which we have to deal with. And here the steel sector should support it actively, this technology push, because other materials like aluminum and especially like aluminum, they are also right now covering this challenge. And this may compensate for a slight decrease in total, because the vehicles on the private side or commercial use side, they will shrink a little bit, but we see new vehicle concepts coming to the market. Here it is needed that, for example, steel has a good communication strategy, like, for example, in this material challenge, that they have a good position. And the steel industry should have this new mobility game on their agenda. So, thank you very much for your attention.
Thank you very much, Ingo, for providing a view into the future of mobility and how steel can play a role there. In the panel, I would also love to have a discussion on the topic of circularity and how steel is comparing to other, let's say, products like aluminum, for example, in some of the automotive applications. Let me introduce Mr. Marcel Hilgers, who will talk about the energy sector.
Thank you, Michel, and good morning to everyone. My thoughts are still with the morning session a bit here, talking about the energy sector, and it was quite sobering, thinking about what we have all to do for our industry and for the future here. But the good news is it's simply too late to be pessimistic. So we have to go on, and I think that all of us are here for a special reason in this World Steel community here. We have good intentions to do something on that end, and I have today here some examples on what do we do with our customers, how do we approach these discussions with our customers, and do we see them moving, and do we see their customers moving actually, and enabling us to reduce the CO2 in steel and in our products. For the Q&A, I will address something here to the Total Energies team. Are they still here? Oh, they just ran away for a reason, maybe. But to the energy industry, really the question is, how will you make sure that it's not only the electricity you provide, for example, or the energy being more sustainable, but as well the grid infrastructure, or the assets you are setting up. Do you think about this, and how do you activate this in tenders? So that I would be interested in later on. Good, so quick introduction to our company, what we are doing, and to put this into perspective, I'm representing here ThyssenKrupp Steel, more specifically ThyssenKrupp Electrical Steel. We are producing one niche steel product, which is grain-oriented electrical steel. 95% of this goes into power transformers. So it's the electricity grid which is driving our activities here. And the International Energy Agency, they expect that the investments in the electricity grid needs to be per year more than 3 times it is in this year in the future. And this is only the announced pledges scenario. So there is a lot to do. I'm not even talking about net zero. And here we are into the game. And of course, there's a lot of CO2 in this grid infrastructure as well in itself, and as well over the usage of these transformers, for example. So electrical steel, what is this? It's a non-grain-oriented electrical steel. You can just think about this. This is a steel in applications which are moving around, for example, e-mobility, motors, generators. And I'm talking here more about the example of GO, grain-oriented electrical steel. And this is, as I said, mainly in grid infrastructure, so transformers. So on our green transformation, I think I will flip over this very quickly because we have talked about the necessity for decarbonization, I think, in length over the last 1.5 days. So let's rather go into the perspective of our customers here. So steel, like cement, for example, concrete is really an essential component for the energy transition. So think about windmills, for example. There's a lot of concrete, there's a lot of steel used in this. And yeah, this is as well the reason why we are converting our production to green to meet this requirement. The question is this welcomed by the energy industry? Thinking again about total industries here, I think I've seen the dollar signs in their eyes, so there must be kind of a connection here. Of course, we are believing that there is an increasing market for CO2-reduced steel. And I come to the facts why we think this is the case. And then energy is clearly one of the markets where this product makes sense. And one keyword is, of course, ESG. And I think that the energy industry is already one step ahead to many other industries, because CO2 reduction and CO2 targets, sustainability targets are much more in the mind of those companies. So we had a look across the industries. Did customers in the energy industry set clear targets for CO2 reductions? And this is based on the Science Based Targets Initiative 2021 numbers. There is somebody from Science Based Targets here, so I don't know if you have an update on us on how it looks in 2022 or 2023, but I think the numbers should have increased massively in the meantime. Pardon? All right, so it has increased for sure. Yeah, so it's more relevant. We have very, very clear announcements as well from leading companies like Iberdrola, Vattenfall, Siemens Gamesa, and so on, aiming for net zero steel. So they make commitments and pledges for this. Now we have to see them moving as well, which is only partially happening. Ørsted has joined the Steel Zero initiative to support this transition. And we have very clear first examples, first movers, like, for example, Amprion, which is one of the German transmission system operators, using transformers made by Siemens Energy with CO2-reduced steel. So these are good projects, but it's pilot projects, I would call it. Here's one more example why it can make sense for energy industries to commit on something. And let's take Iberdrola, a major international player in energy. So they have expressed quite clear targets on emission reductions. They have a very clear commitment as well on being part of the climate group Steel Zero. They are claiming these targets based on the Science Based Targets Initiative. So there is well, I'm German, so it's like a penalty kick without a goalkeeper, yeah? That CO2 reduced steel makes sense for these companies to reach their targets. Others are as well in this area, and these numbers are probably 1.5 years old, so they have surely increased, and more companies are joining. Here's one very concrete example, and we're breaking it down again to the transformer sector here in Enel. They are looking very much at a green transformer. So what is a green transformer? Of course, you look at the life cycle of the transformer, so 40 years in operation, how efficient is it? We talked here with the building sector, for example, of reducing the size. So this is everything what you can do if you use more noble materials. So there's a potential as well next to the CO2 reduced steel itself. But this will become part of their tenders right now, which is very encouraging for all of us here. So now the question is, what can we offer as the steel industry? Yeah? And I will jump over this very quickly. There is, of course, today already in the transition phase to CO2 reduced steel from DRI and other technologies, options available which provide solutions for energy industry players to reach their targets. And here's one very concrete example on two transformers, power transformers. What happens if you equip them with CO2 reduced steel, cradle to gate? Yeah. If we look at the left side, so this is a 120 MVA power transformer. So this is maybe as big as one of these tiny houses we have seen before, yeah? This transformer. And it has a steel core, only the magnetic core, of around 75 tons. So if you simply take this without any additional measure and equip it with a CO2 reduced steel, our example here of our product we are currently offering, then the cradle to gate emissions go down by 20% or 18%. If you go to smaller distribution transformers, the amount is higher because the impact of the core is higher. So it has a significant impact. And here one more example, because it's sometimes hard to grab what is 1 ton of CO2, yeah, and how meaningful this is. We have one use case here. I mentioned this earlier. Siemens Energy has built transformers for Amprion and ENBW, transmission system operators for DC connection, green electricity from the northern shores of Germany down to the south. And in one converter station of this, there's around 13 transformers. One transformer equipped with a CO2 reduced steel saves 240 tons CO2 cradle to gate. So the question is this a lot? And what else could Amprion, TSOs, the customers of our customers really do to save as much CO2 like this coming from their scope 3 CO2 balance sheet here? So it's a lot they would have to do. You see some examples here, and I think that sustainability managers, yeah, really have to carefully think where's the biggest lever in the products we use, in our supply chain to reduce our CO2 footprint here. So we talked about, one keyword was collaboration here earlier. Yeah? In the past, in my role as being responsible for sales, I was talking to the commodity managers of our customers, to purchasers and so on. What is happening now is that I'm talking, I think 40% of my work time with our customers or with the sales managers of our customers or sustainability related teams and people of our customers. And when we think about big companies, they know how to set decarbonization targets. But when we think about the many small and medium-sized companies who are producing transformers in that example, they have no clue on how to approach this topic. So what is needed, I think, in our industry is that we are collaborating as well on how can we make sure that everyone has the right data sets, has the right means to provide the information which the customer's customer, like the transmission system operators, need, that they can generate this data. So knowledge to decarbonize our products or the transformers is very much needed, and we are trying to support this together with our customers. Here's one more concrete example what we are doing. We have just joined this joint industrial project led by DNV, and it was initiated on a sustainability conference for the transformer market. So a couple of industry players came together, transformer makers, utilities, raw material suppliers like us, copper suppliers, and so on. And we said, our customers, they want to have decarbonized or CO2 reduced grid assets. How can they introduce this in tenders? So really request this. And how can they make sure that they get what they really want? And the answer was, there is no way that they can get this. Yeah? So the industry is not ready for this. There is no clear rules for this. So we decided, okay, let's come together under an independent leadership here of DNV to discuss in this group of industry players, how can we bring this forward? How can we create solutions which we can later on probably suggest for regulation or for norms, so that, and let me give you a very concrete example, that a company like TenneT, transmission system operator, they have tenders out for billions of euros on grid infrastructure. And they want to, of course, become more sustainable as well for these grid assets. And they're having good initiatives on this. But how can they make sure that their suppliers are applying the same rules of providing information to them on the CO2 footprint of the grid assets, for example? And this initiative here is there to spark this discussion and to create solutions here. So I think that here in the room there's a good couple of organizations as well who are working more or less in the same direction, and I think it's really important that we come together to do the right things together here. Closing this, we are in a transformation phase here. We need, of course, fair competitive conditions. We need this political regulatory framework, but nevertheless, we need to we need to go ahead ourselves in the industry. So not only looking at the regulatory, we need to propose something, as the topic is really complex. Required next steps, of course, green lead markets is a big topic. I was talking to some people here around this. How can we make sure that green lead markets are created now? Again, the example, Total Energies, you got the commitment or that you got the confirmation in this year for setting up something in the North Sea in 7 or 8 years. So it's better to have something done right now, because if we don't act right now, we will build these things in 8 years and there will probably be no sustainable material required in this. And that cannot be. So we need to act really right now. So closing this with this appeal here that we can only do this together. And thanks for your attention.
Thank you. Thank you very much to the three presenters, actually, for three excellent presentations. I think now is the time for a panel discussion. And before I open the floor for questions, I have prepared some challenging questions to our three panelists. And I would like to maybe start with a first question to Olivier. Marcel mentioned in his presentation that the energy sector has set quite ambitious decarbonization targets, and I understand that the automotive sector, which is quite a consolidated sector, has also set very ambitious Scope 3 decarbonization targets. The construction sector is still the largest sector, or the largest offtake for the steel industry, and I was wondering, Olivier, if also in your sector you see these Scope 3 decarbonization targets.
Yeah, we see that, but not really in the same way. It means that most of the companies active in the construction sector are SMEs. It means they don't have any carbon reporting, they don't even know what is Scope 3 and all these type of things, because they don't care, they aren't listed, they don't need to report this. But what we see coming, it's regulations, so coming from the member states, which are imposing to the real estate world a CO2 quota. So we see that popping up in several countries. We know that many countries are looking at that. So if I take example of France, they have put a regulation that all the buildings have an amount of CO2 equivalent per meter square built. They have a target, and this target will decrease progressively. So when we look today, it's achievable. It means if you do a good design with normal material, you can achieve it. But the threshold is going down really quickly. If you take the threshold of 2028, you cannot build this building in concrete anymore. It's not feasible. With the available technology, even the low carbon cement they sell and so on is not sufficient to reach the 600 kilo per meter square built. It means that the market will need to have a switch in terms of combination of material and will need decarbonized material just to reach this target. If you take the Nordic country, it's the world upside down. The customer put far more pressure than the member state. It means today, when you look at the customer, the stockist, the builders in the Nordics, they barely all already purchase decarbonized steel. I will not say decarbonized, I will say steel with low carbon, because remember, EAF is really low, so for them it's easy to reach, but it's the way they push. So it will come by the regulation, but not by these Scope 3 and so on, because construction companies are not listed.
Thank you very much. Very insightful. And I think in the construction sector, because of the properties of steel, I mean, except for, of course, the substitution with concrete to a certain extent, steel has a stronghold. But maybe a question for Ingo in the automotive sector. Where at the end you mentioned that steel is in competition with aluminum. The automotive sector also increasingly is setting targets on circular content of the materials that are being used in the vehicle. And I was wondering, do you have a view on, in the automotives, how steel is comparing with aluminum, potentially also other materials? You mentioned basically that it has a good value proposition, but are there any risks or anything that this group needs to know?
Yes. Okay. Yeah, thank you for this question. I think this is a very important, or this is already an important race between steel and aluminum in this automotive game, because, like I said, in the established world, for sure, we have also established processes behind, and I think steel is still well established when it comes to volume OEMs like Volkswagen and so on, because there you are in a very, very cost-sensitive way. It is not only cost, but also from the LCA perspective and so on. But when it comes to new concepts and also new challenges which arrive on the market, it's not only the tech companies, all these Chinese players, for example. They begin from the scratch, they begin open-minded, and they look at every material. So, and also the aluminum industry, for example, is coming up with new solutions. Maybe one of you have heard about mega castings. This mega castings which are now introduced into the automobile industry, like Tesla, for example, uses this, like Volvo uses this, for example. So this means that they are doing component integration. So, and that, for example, this is also much more beneficial for for the calculation in this circular, because you do not have to deal with 10, 15 components and has to run it through the cycle. So you have one component, maybe with some disadvantages also in terms of LCA, in terms of aluminum, but maybe they get rid of that because they're doing this huge part integration, for example. And this is for us at the moment a thing the steel industry should look at. I would not say at this moment it's a threat, but they should look at, because it's just nowadays a premium phenomenon, because when automotive industry is a little bit different, because we have these premium vehicles and premium OEMs, and we have these volume vehicles and volume OEMs. So I think the threat is already in this premium sector, and we have to see in the future if it also declines into this volume sector. And then it can be a real threat for steel.
Okay, thank you very much. Maybe pivoting a bit from, let's say, that target and aspiration towards the solutions, and in your presentations, you gave already, let's say, many ideas, many pathways of how the steel industry is helping the downstream sectors to decarbonize. But I have a question for Marcel, which is, as an outsider, so we do see various low-carbon offerings being introduced. You gave the example of Bloomint. I think ArcelorMittal has X-Carb, Tata Steel has Zeremis, and so forth. Now, as an outsider, all these products use a bit their own baseline, their own reference, have a different calculation methodology. Do you have the feeling that, is there anything else that the industry could do to enable decarbonization more quickly or more easily in a more transparent way for the end user industries?
Yeah, that's obviously a quite complex topic, but I think this is addressed here by World Steel and by the different organizations which are here in the room as well. So I would like to focus a bit more on the end user view on this topic here. So we need to learn from the end users as well. What is it what they need? What are they really looking for? Are they willing to go through the transition phase together with the steel industry? Because it takes a while until there is the full decarbonization or the CO2 reduction for blast furnaces, for example, available. And this is what we need to understand. One critical thing is, I have seen tenders for grid equipment right now, which is requesting sustainable steel products, or sustainable products. But there is, in the small print, there are so many exceptions and so many rules that I think the companies are not really, they don't really even know how much of the potential CO2 savings and reductions they are excluding by these by this small print. And this is what we need to understand. The next topic on this is green lead markets. On when green lead markets are created, what kind of products would be certified for these green lead markets? We need to get into a discussion there and find solutions quickly, because otherwise, again, we decide things today which are installed in 7-8 years.
Thank you. Thank you. But obviously, many of the let's say the solutions that were proposed and discussed are quite costly. If you think about, ripping out the blast furnace, putting, let's say, these DRI units in place and so forth. So the question that I would have is also, is the downstream sector willing to contribute to this transition financially, to make the business equation for the steelmaker work? I don't know if any one of you wants to make any comments on that.
Yeah, if I may, of course we are not allowed to speak about price and all these things. But in construction, it's quite difficult in a way that our customer, they don't have the power of price. It means they are most of the time the subcontractor of the subcontractor of the subcontractor. So they are squeezed really a lot. So Barely each penny is counting when you talk about construction. But we need to put the scale into perspective. The premium, which is announced on internet, if you Google premium for green steel, is something like 200 euro per ton. In a building, 200 euro per ton corresponds to 1 to 2 euro per meter square built. So when you sell your office building in London, £20,000 per meter square, what is £1? You know, we have really strong discussion with our customer on 50, 100 euro per ton, and at the end, this represents less than £1 per meter square built. And then they would put a beautiful wood flooring, which costs 400 euro per meter square build. So this conversation, we need absolutely to have it with the real estate world, to make them understand that decarbonizing is in fact really cheap. And due to the scale of the market, to get these 100, 200, even 300 euro premium on green steel is peanuts for these investors. But as the power of pricing is squeezed and squeezed and squeezed, the people who need to purchase, they don't have the money to purchase the green steel. So we need absolutely to act at regulatory level, that's the stick, and to have this discussion with the real estate investor and the end user to help them to market this.
Surprisingly, it's the same in the automotive industry. The gap between premium and, like I said, the mass or the volume manufacturers. So I think when it comes to the premium OEM, you always can have a premium uptake in price. But what we have learned now in the last month or in the last year, that especially in the volume sector, the suppliers were squeezed out, but not by reducing the manufacturers' demand in terms of the CO2 benefits the suppliers can bring to their product. So surprisingly the same, but yeah, the same game, and I think it always has to be, like I said, cost sensitive, and in this volume sector, with also the customer who cannot afford to buy a vehicle, like actually the electric vehicles, we talk about 35,000, 40,000 euros. This is not a vehicle for the masses. So also there, the costs have to come down, and yeah, price uptake then for green steel, for example, it will be difficult.
So I got 3 points on this. The first one is on a personal note. It took me personally a while to in the supermarket to take from the shelf the sustainable bamboo toothbrush instead of the plastic one. Meantime, I'm doing that, but that's only a very little thing, and I think that everyone in the world is thinking like this, probably, unfortunately. And second point is, I think we will see a break even anyway, so that at a certain moment, when, for example, take Europe here, the free emission certificates are reduced, we will have green steel or CO2 reduced steel becoming cheaper at a certain point in time than grey steel. Then a third point, when I was addressing the fact that I was talking more and more to our customers, and none of them has ever, when we talked about costs, said that the costs are the decisive factor, that they are not going for a green steel solution. So it's much more regulation, because many companies are regulated and they are somehow hiding behind that thing, that they are not moving because they are regulated, and green lead markets have to be created. So a good mix of the punitive side and incentivizing side, I think, is necessary, and then we'll get there.
Thank you very much. Besides the financing and the business case, are there other roadblocks or constraints that the steel industry is facing? I mean, we hear a lot that notion of, in the future, value chains will have to collaborate much more intensely to develop solutions. Any other thoughts on that? I don't know.
Yeah, as I put in my presentation, the solution is not only the decarbonized steel. It means that as an industry, we need to propose to the market a solution that will optimize the steel use. I think it's a bit the same in automotive. If we want people to afford this new electric car, yeah, we will need to have, of course, a part on the cost, but also a part on the use of the material. And also, our supply chain has a role to play. I take the opportunity that our friends of Total came back. I saw in the presentation that you need to build 100 gigawatts in the next year. With Annie, we made a bit of math. This will correspond to 10,000 approx. 10,000 offshore windmills. Each offshore windmill is about 1,000 tons of steel. So it means just in this part of your plant, you will consume something like 10 million tons of steel. So we will be your customer to purchase the renewable energy, but first, you will be our customer to build these windmills. So if giant company like you are also pushing towards the use of this low embedded carbon steel, that will feed the pump, because I think it's like the chicken and the egg. If the market is not there, people will not put billions to put the RI, and you will not build your network, because we don't need the energy. So I think we need the big industries. We need to work together really to start the machine, and then all the SMEs and so on will follow.
You mentioned this schizophrenic lever for the industry to reduce demand, to increase reuse and refurbishment and so forth. I'm wondering from a steelmaker point of view, how can you make this a win-win? What's in it for your company to actively promote such solutions?
It's really simple. Today I take Europe because it's the market I know the best, but I think it's approximately the same on the planet. If I take market share of steel in construction on an average, it's 25%. It means I prefer to have 35 or 40% market share with less steel per building, but more noble steel and lower environmental steel than to stay in the status quo today and just deliver rebar to the concrete industry. So that's the way I see the evolution of steel. We need to gain market share versus alternative material. And when I look at the plan of cement industry, they don't have yet really a plan. It means that today, what I see on the market, it's substitution of cement by blast furnace slag, some carbon capture in their production. But I don't see yet, even at scientific level, because at the basis I'm a scientist and I still follow that. I don't see publication on technologies that will enable them to really produce decarbonized cement. And I see a lot of publication on startups and so on in steel with new technology. I don't know if they will scale up, but I see at the science level that things are moving. So it's clear we will capture more market share by selling less steel in the buildings.
Very interesting. Let me open to the floor for any questions to our panelists. There's one in the back was the first one. Sorry.
I was quicker. It's Renata from Anglo-American. Pardon my ignorance, but today when you speak about advanced high-strength steels for construction sector or the grain-orientated steel that use in transformers or supposedly some automotive steels, are they made through BOF route or are they made through the EAF route? And is there the difficulties, different demand for raw materials and ore-based metallics, that as a result of that changes? And it's not trying to catch you out, I just genuinely don't know.
So the grain-oriented electrical steel we produce is made from BOF, yeah? Production technology, as we are operating in this way in our company, and it's one of the most complex steel products. So to make it from a scrap product is close to impossible from our perspective.
So if I may, for construction, I would say most of the construction product can be done with EAF. So I don't see big technological issue to do it. Beams in high-strength steel, rebars in high-strength steel, plates can be done via the EAF. Of course, we have our history of production. We have some producers which are BOF, some producers which are EAF, but there is no technological issue to switch from one to the other.
From the automotive perspective, I'm not the process expert, but like I've shown on my slides, there is again the demand for this passive safety and the advantage or the position steel has in that game with the advanced high-strength steels. I think is also a good starting point for them. To bring in that solution into this new automotive world. Like I said, I'm a lagging expert what the processes mean. Sorry for that.
There was another question.
Well, okay, Max Amann, Lund University. Actually, was an excellent question. It was the one that I had intended to ask. But okay, but I will just give you, I will just tell a story when it got. Who's willing to pay for green steel? I mean, I've heard this from a Scandinavian green steel developer that basically said that if you ask the procurement officer in any manufacturing industry, it's no. That's their job. But if you ask the CEO, has a strategic value, it is actually quite easy to motivate a quite high premium. So I don't know if you have any comments to that. That is, I think it's also been mainly shown by the large number of offtake agreements now flourishing within the green steel market.
I fully agree. That's clearly the answer. And as I mentioned now a couple of times, talking to our customers, yeah, the answers are very, very straightforward. So price has never been really the decisive factor on this. Yeah, it needs a strategic decision and the right, sometimes regulatory approaches as well, green lead markets, yeah, that everyone is jumping on. And especially when you go to small and medium-sized companies, then here it's a bit more difficult, and they need to follow the big ones. So we need pioneering, big, bold moves from big companies.
Hi, I'm Andrew Forth from Climate Group. I work on our Steel Zero initiative, which Marcel, you referred to in your presentation, so thank you. Just to follow up the last question, how aware do you think the politicians who are making these decisions are of the role that they could play with the purchasing that the government does, either directly or indirectly, of steel? Because in most countries, 20% of steel can be directly related to government purchasing, and it seems an underused tool for policymakers.
Yeah, that is a very good question. I think that the knowledge is not enough in many areas. So we are supporting our customers, and we are ourselves now joining a lot of conferences, giving presentations to governmental organizations or organizations which are there to support governments on what is in for the industry, what can be achievable, what do we have to offer in order to make them reach targets and to move. But we need much more activity in this field, and as well alignment over the industry to avoid misunderstandings or bad feelings on misconceptions here.
Yeah, if I may react, I'm involved in many, I would say, bridges project, infrastructure project in Europe, and I must tell you, they are not aware. They are not knowledgeable. I know it's not politically correct to say this, but it's the case. So they know barely that they will need to buy green things, but they have no idea at all of what does it mean. They have no idea at all about what is available. When you discuss with high-level politicians, which are a bit active in the construction sector, when they think green, they think wood. They think about wood, because there is this image of wood. They have an idea that concrete is bad. Fortunately, it's something which is popping up, but concrete industry and cement industry are really fighting and really discussing a lot and lobbying a lot on the government and on the politics. And for steel, they don't know. They don't know if it's bad or wrong. And I think there we have as associations, because I think that's really the role of association like worldsteel. It's to have this dialogue with the politics about the steel.
Yeah, also maybe just one comment to that from the automotive perspective. That's a very, very good comment, because this was also a lot of the discussion when it came to the CO2 targets for the automotive industry. Politics gave guidelines, but they were not concrete enough. They're always told, you have to do that, and then come up with a solution. We are just saying we are technological, we are open to every solution. But that's not only the best and efficient way to go to or to overcome those challenges, because in the automotive industry there had to be a lot of investments coming from the internal combustion engine to an electric vehicle. And think about the steps in between. We talked about hybrids, we talked about plug-ins, and this costs so much money, and they put in their efforts. And now you see that, for example, for plug-in hybrids, the subsidies, for example, in Germany will skip, and the plug-in hybrid is busted out of the market. So, some more concrete guidelines would benefit, also in terms of material usage, from the politician side, would benefit more the efficient approach to such challenges.
I think we have time for one or two more questions.
I'm Rutger Gyllenram. I've been working with standardization, environmental standardization for constructions. And when you build a construction or design a construction, you have a design phase and a construction phase. And during the design phase, it's not decided whether it's a wood building or a concrete building or a steel building. That's often the case. So my question to you is rather general. Do you think that the end users need to change their way of designing or their design processes in order to really use the advantages of high or very efficient materials?
Yeah, it's a really good question, and I would disagree on the fact that at design stage it's not decided. They think it's not decided, and that's the big problem. The choice of the material is decided the first day one, when the architect is doing the first drawing. Because if you are a good engineer, you cannot design a building in steel if it has been drawn by the architect to be in concrete. And that's always what I try to teach to my students. Because already at school, at university, they are convinced that 8.1 by 8.1 grid is the magic grid, and they must use that. And if they increase the span, it's more expensive. That's clear. When you think in concrete, when you act in concrete, you increase the span, it's more expensive. In steel, you increase the span, it's less expensive. So when you draw the first day, it's already settled. If you draw a concrete building, it will be done in concrete. If you draw a wood building, it will be done in wood. And we always arrive, and our customer always arrive too late when they try to change. But when you need to change architect's mind. You need to change the dimension of the building, the size of the building. So it's always too late. So we need to pop up day one and convince the architect and that they need to change the way they think about building. Yeah, it's hell of a challenge.
Okay, well, thank you very much for this great discussion. If I take a bit of a step back, there's maybe 2 or 3 learnings for me. The first one would be, it looks like the steel industry is really one of the leading sectors in the field of decarbonization. There's a clear pathway, there's clear ideas there, and compared to some other sectors, concrete, whatever, let's say the pathway is more clear. I would say that's one. The second thing that I take away is a good combination of the stick and the carrot is probably the right combination of incentives to continue this momentum. And then the third thing that I take away is, let's say, I don't want to comment on the political, because that could also be a takeaway that maybe the awareness with politicians can still be further raised on the important topics. The third thing that I would say is early involvement in the design, in the material choices is important because, you know, many of our solutions are long lifetime solutions, and so the earlier we can intervene, the better. I would like to thank the panelists in the first place and also the room for the great questions.